Good morning, everyone. I'm Linduni Rodrigo, and my PhD study is about Bayesian, how we can use Bayesian variable selection techniques for efficient learning of graph structures. Okay, so to start, we know that modeling environmental data is really challenging. There are two main reasons because it involves lots of variables. And interestingly, they are interconnected. So what we need to do, it is important to identify, understand these connections between variables. So learning this relationship, we can say it involves understanding what are the important variables and use this variable selection techniques often in the graph structure, graphical model framework. Because Emma actually given you a good introduction about the graphical models, the kind of graphical models that is called the Bayesian networks. The important thing in graphical models is that has the ability and it allows the multiple relationships among variables. And consider all the variables as X variables. And it has ability to identify both the strength and as well as the direction of the relationship. So my study going to develops a new variable selection technique that outperform the current methods such as spike and slab and horseshoe, and use it in the form of graphical models to model complex environmental systems. Okay, so Bayesian methods in variable selection actually treat the parameters as random variables. And the different Bayesian variable selection techniques is based on the prior that we use on the model coefficients and as well as the other parameters. Okay, so in this study, we consider two different prior, which is the spike and slab and the horseshoe. In the spike and slab, it uses a mixture of two distributions on the coefficients, as well as it introduces a discrete indicator variable, the gamma, which we interpreted as the prime inclusion probability. And it is a Bernoulli, it should be a Bernoulli random variable, and it has values 0 and 1 exactly. So the problem is this spike assigns the coefficient to be exactly 0 to represent noise, and as well as the continuous slab represent the signals. So, but the problem is in spike and slab is that it gives a rise to discrete posterior distribution where the derivative doesn't exist. Horseshoe, on the other hand, mimics this problem by introducing a continuous indicator variable where the expected, which is the kappa, where the expected value of kappa given the data, we interpret it as the amount of shrinkage towards 0 for a certain coefficient. And it places a continuous beta prior with constant parameters. And this is good when in the situations where we are interested in small effects close to 0, but not exactly 0. However, the interpretation of kappa make it difficult to decide whether a certain variable is in or out by just itself. Okay, so we introduce a prior that also uses this same indicator variable, gamma, that is in spike and slab. However, in this case, it is not discrete. It is a continuous having a beta distribution. but again, with the varying parameters. So the important thing is when you look at, so when the hyperparameter U goes to 0, it shows the characteristics of spike and slab. And when it goes to infinity, it becomes the slab and shows the continuous nature. And yeah, so this prior is too better in interpretation of whether variables is important or not compared to horseshoe. Okay, so simulation results shows simulation results of this new prior compared to horseshoe and spike and slab shows a gives us the closest estimates to the true values, even when the variables are highly correlated. When we increase the number of variables, still including highly correlated variables, we do best for the almost all the cases, except for one variable here. So even though horseshoe does better for that, we also produce a good estimate for that. The real environmental data that I'm going to use for this to illustrate this method is still under discussion. So I still don't have enough data to show that. So it is about to look at the relationships among algae blooming with the several water quality factors as well as climate factors. So for now, as a TOE example, I use the monthly rainfall data to show how this works. Okay, so for that, I have chosen 6 indices of ENSO effect, the Southern Oscillation Index, IOD, and SAM, and some NINO indicators, which are based on sea surface temperature. And also I have included, the interaction, all the interactions of first 3 indicators for the model. And yeah, so if we based on the gamma threshold to be 0.5 to understand the important variables, we can see that SOI and the interaction between IOD and SAM, as well as 3-way interactions, are the most important indicators in predicting rainfall in Sydney in month of March. And it is good thing that significance of the ML estimates also agree with that. Yeah, so that's just a store example. To sum up, that we have examined the performance of the commonly used variable selection technique, which is spike and slab, and we can say kindly recent one, horseshoe prior, in the linear regression context. And we have introduced a new prior that outperforms these 2 methods in terms of accuracy. But when we consider the speed of it, we beat the spike and slab. However, horseshoe is a little faster. So what we are working on currently is to improve the speed of our method because we use MH as the sampling scheme to generate gamma posterior. So we're going to use HMC instead, so that we think we can improve the speed. And also then we're going to apply this in graphical models to efficiently learn the structure. And we'll definitely apply, we can definitely, I hope this will be useful in modeling complex environmental systems. Thank you.